So one conclusion I would draw from the theory of time relativity is that there is no space-time continuum. What there is a wrought continuum, and space-time exists at various points along it where gravity, matter, and slowness of time all exist in proportion to one another. At this point, I must reference Edward Tyron, who postulated a zero-energy universe in 1973. That is where all the gravity that exists in the universe is the negative cost for all the energy and matter that was created. Now, the hypothesis seems to be supported by the theory of time relativity, only with the added inclusion of time into the mix. With regards to wrought, I see no reason to believe that it's not infinite in both directions. And now this may cause consternation for some people, but it also is problematic in terms of visualization. So at this point I would refer you to Mandelbrot's fractals. This is a useful tool, I believe, in trying to visualize how the theory of time relativity works. Now we know they're infinite in detail, going down and going up in terms of scale. But if you pick a point on a fractal and use that as a reference point, it seems to mirror quite well what we experience in the physical world. And that is that from that point, looking out for detail, we tend to run out of information at larger scales very quickly. And this seems to be our experience looking out into the universe. When we're looking down into the detail, we tend to have a lot more information in terms of the structure. And that tends to be what we've experienced. Looking into biological systems, looking into atoms, and now into particle physics, we seem to get a lot more information at the smaller scale. So I believe this is a good mirror as to the workings of the theory of time relativity.